This lesson is about addition, subtraction, and multiplication of polynomials. So how do we perform these three operations? So let's start first with addition and subtraction of polynomials. For this one, we have to learn the term like terms or similar terms. Okay. So when we say like terms or similar terms, we have the same literal coefficient. So in our previous lesson, we talked about literal coefficients. So they are the variables with the exponents. So we have to have the same variables with exponents. So below here, I have a polynomial, and let's identify which are like or similar terms. So for the first one here, our literal coefficient here is x. So this one is similar to this term. So they are like terms. Okay. For the second one, the literal coefficient is xy. So the second term here is similar to this term. So they have the same literal coefficient. While 5 doesn't have a like term, and negative y squared doesn't have a like term. Okay, so how do we perform addition and subtraction? So we can simplify further this polynomial. So even though there's no polynomial plus a polynomial here, or there's no polynomial minus a polynomial, we can simplify polynomial. Simplified form is we have to combine like terms. So how do we combine like terms? So for 2x, we just look at the coefficient or the numerical coefficient. So in this case, it's 2 plus 1, so positive 2 and positive 1. So this is 3x, and then we have negative 3 and positive 7. So we combine or we simplify, so that's positive 4xy. And then since we don't have any like terms, so this is just plus 5, and there's no like term for y squared, no, so negative y squared. So this is the simplified form of this polynomial. Let's have some polynomials to add or subtract, no? So sometimes it says here that if you're doing addition and subtraction, you're also trying to remove parentheses and combining like terms. Okay? So again, no? So if you combine like terms as what we did previously, you're just adding their numerical coefficient. So we're going to simplify this by removing the parentheses and the bracket. So the first thing that we can remove are the parentheses. So if we look at this one here, that's 2x. Okay, I'm not going to remove the bracket yet. And what does this mean? It means that you're subtracting this polynomial or this binomial. So how do we do the subtraction? You multiply negative 1. Oh? So you're multiplying this by negative 1. So this is negative 3b, and this one is negative a. Okay, so if you notice, we already removed the parenthesis. Then, for this one, again, I'm not going to remove the parenthesis, the bracket, only the parenthesis. But since this one has no negative before, so that's just 2a minus b plus 5b. Okay, now let's see if we can simplify things here. So if you notice, there's no like terms here. But for this one, there's a like term. So you can have two options here. It's either you take away the bracket by multiplying negative 3, or we can just first simplify. So what are the like terms here? Negative b and positive 5b. So that's positive 4b. Okay. So for the next step, I'm going to remove the parenthesis here. So that's 2x minus 3b minus a. And I'm going to also remove the this bracket here. So I have to multiply negative 3, okay, to each of the terms. So please don't forget that you have to multiply it to each of the terms. So that's negative 6a minus 12b. Okay, and then again, for the last step, we see if we can look for like terms. So we have like terms here, negative 3b and negative 12b. So that's negative 15b. And then for this one here, we have negative a and negative 6. So negative 7, 8. So that's the simplest form for this one after we move all the parentheses. Okay, so let's have another example. So this one, we have two operations. Okay, so let's read the problem. Subtract the polynomial from the sum. Okay, so that means we have to add this first. Okay, so we can just automatically look if we have like terms. So here we have x cubed y, and we have y cube also. No, it's different, right? Okay, so since they are not of like terms, okay, so there's no like terms for x cubed y, right? So when we simplify, we simply have 2x cubed y. Okay, so how about x squared y squared? So we have 3x squared y squared, and here for the second polynomial we have negative 5. So if we are going to combine, positive 3 minus 5 is negative 2x squared y squared. Okay. Next one is negative xy cubed. So this one, they take note of the negative. You also have here a positive 6xy cubed. So they are like terms, so that would be plus 5xy cubed. I have the negative here. And then lastly, you have 2y raised to 4. So this is the sum. So this is the sum that we got, right? Okay. Now, what do we do next? It says here, subtract this from. So let's review our meaning. So that means this polynomial, no, minus, because you're going to subtract this from. So let me just write it down. So minus x cubed y minus 4. So I'm just writing everything down. I'm not doing any computation at this point. Okay, there we go. So I'm going to take away the parentheses since there's no more like terms here. So I'm just going to write this down. I'm not solving anything at this point. Okay, and I'm going to multiply negative 1 to each of the terms. Okay, so that would be negative x cubed y, negative times negative, positive 4x squared y squared, and then negative 5y raised to 4. Okay, so since we have already multiplied the negative 1, all we have to check now is there similar term again? So we'll start with x cubed y. So yes, we have an x cubed y here. So if we simplify that, that would become 2 minus 1. So it's just x cubed y with positive, because positive 2 is bigger than negative 1. Okay, so 2 is bigger than 1. Then the next one here is we have x squared y squared. Oh, we also have x squared y squared, similar or like terms. So that will be plus 2x squared y squared. And then for 5xy cubed, there's no similar term. So I'm just going to have that. Okay. And then lastly, have 2 and negative 5, which would be negative 3y raised to 4. So it's fairly simple with addition and subtraction of polynomials. All you have to do is, in subtraction, you have to multiply with the negative, okay? That's the only thing that you have to remember. And then if it's just addition, you just have to simply combine the similar or like terms. Okay, now next one will be for multiplication. But before we go to multiplication of polynomials, let's review first some laws of exponents. Okay, so what we have here is if you have a raised to x, okay, so we call this the base, and x here is the exponent. So let me give an example to illustrate this a raised to x. Okay, so let's have a simple one. So example, we have 2 raised to 3. Okay, so that means here you have 3 copies of 2. You're multiplying 3 copies of 2. So if it's a general a raised to x, that means you're multiplying x copies of a. Okay, so look at this law of exponent here, and let's make sense of this. No? So here we have x copy plus multiplied to y copies of a. So I'm going to illustrate number 1 here. So let's say 2 cubed times 2 raised to 5. So this means you have 3 copies, and here you have 5 copies. So basically, we're just multiplying the sum of this, which is 8 copies. Hence, you're just going to add x plus y. Okay, now this number 2 is the one that you get interchange with number 1. So what is the meaning of this number 2? That means you have y copies of this a to the x. Okay, so let's illustrate. So I'm going to use a smaller value. So that means, let's say I have 2 cubed raised to 4. So what is the meaning of this? This is not 3 copies and 4 copies. So you have, I'm going to use a different color for the inside. That means these are 3 copies of 2. Okay? And you're going to be repeating that 4 times. Okay, so 1, 2, 3, 4. So that's why it's multiplication, because you have 4 copies of 3. So diba, that's 2 raised to the product. Hence, it's x times y. So please don't get confused with the meaning of ax times a raised to y. You have another base here, right? While for number 2, you're raising everything, including the exponent, to another exponent. So that's the difference between the two. Okay. Now, for number 3, you can do this. So if you have multiplication, you can simply first have x copies of A times x copies of B. Or you can multiply first A and B and then do x copies. So please take note, these are the common mistakes. So you cannot do this over addition. Okay, so this is wrong. This is not correct. And you cannot also do this over subtraction. So these are some of the common mistakes that people do since they saw that you can look at number 3 and look at number 4, right? You can apply that also over division. So for example, that's, let's say, 2 times 3 raised to 5. Okay, so what we're saying is that this can be written as 2 raised to 5 times 3 raised to 5 instead of multiplying this as 6 raised to 5. So you get the same answer, but sometimes it's easier to compute when you're dealing with a smaller value. So for multiplication and division, you can do this, but it's not applicable when you have the operation addition and subtraction. Okay, now, how do we simplify exponents? Okay, so here, number 5, you have a to the x, a to the y, so you just subtract. So let's illustrate number 5. So what does this mean? Let's say we have 3 copies of A and 5 copies of, my A here is 2. So if I'm going to do this and expand, this is the meaning of this. So that means we all know that 2 over 2 is just equal to 1. 2 over 2 is equal to 1. So we are left with uh, 1 over 2 squared, or 4. Now, how do we apply the formula? So if we apply this formula, you'd get 3 minus 5, right? And this is 2 to the negative 2. So how did it become 1/4? So here, number 6 together, when a base is raised to a negative exponent, there's no meaning for this. So you cannot solve for this right away. But what you have to do is to change this negative exponent to a positive exponent by doing a reciprocal of this whole thing. So it's equivalent to 1 over 2 squared. Hence, we get 1/4. Okay. Okay, so let's say if you have this fraction and it's raised to negative x, so you can automatically take the reciprocal of this and your exponent becomes positive. Okay, now some of you might know there's another way to do number 5, right? You're going to right away do the difference in the denominator. So some of you can go directly here. So you know that step wherein you pick the one with the higher exponent, then you would have the difference here. Yes, because the higher exponent means you have more copies. So if you have more copies, you'd have an extra on the numerator or denominator with the higher, with more copies. Okay, so you can go directly here. Okay, you don't have to go through this process. Okay, so why are we discussing this loss of exponent? Because we'll be needing this when we do multiplication of polynomials. Of course, in multiplication, we'll not be using everything. Okay, so usually it's just number 1, number 2. No, that's the most of the law of exponent that we'll be applying for multiplication of polynomial. So for the first example here, I have here a monomial times a monomial. One term, one term. So if you look at the second one here, I have a squared. So I will apply, look, they are all multiplication. So I can apply the law of exponent number 3. I can multiply the exponent to each of the exponent here. So what will happen? I'll copy first the first monomial. On the second monomial, I will be distributing the exponent. So that's 5 squared. I can just write 25. And then this is raised to 1. So 1 times 2. Okay. And again, you multiply. Okay. Because you are raising everything to 2. So 5 times 2, 10. And then this is 6. Okay, so afterwards, we're going to apply the first, the constant times constant, which is negative 50. Now, look at this one. This is different. Okay, so that means there are 3 copies of x and 2 copies of x. So altogether, we have 5 copies. 2 copies of y and 10, so that's 12. And then 1 for z and 6, so we have 7. Okay, so this is a short multiplication. So for this one here, notice that there are 3 terms here. So that means I have to multiply to each of the term. Okay, what we call the distributive property. Okay, so again, multiply the constant with a constant. 6a, 1 copy, and 2, so a raised to 3b. Positive 3 times negative 3. Okay, so you have an additional copy for b, that's b squared. And then 15, additional 1 copy for a, and another copy for b. So that's how we do a monomial times a polynomial. So we have an example here next for the long division. No? So for the long division, we have to look at each of the term here and multiply that to each of the term on the other polynomial. Okay, so we just repeat. It's just a longer process. No? So we multiply x to this one. So the numerical is just 1. So that's 3x squared. And then minus, there's no x here. So that's xy. And then positive 1 times 5 is negative 5. And then we have your x. Okay. Then you move on to the second term, and again, multiply that to each. So 2 times 3, that's 6xy. And then you have 2 times negative, so negative 2y squared. And then negative 5 times 2, negative 10y. And lastly, we have here the negative 1. So this is easier. We just multiply negative 1. So negative times negative becomes positive. Okay. And then last step is to look for similar terms. So do we have an x squared? No. Okay. So do we have xy? Yes. So we simplify this. We have plus 5xy. Okay. Do we have a like term for x? Yes. So negative 8x. For y squared, there's only 1. So copy. Then for y, we have similar term or like term. So negative 9y. And then for the constant, there's only 1 also, plus 5. Okay, so that's what you call the long division. Others, they want to do that in column. So you can also do that. Another version is, this is an alternate, is they want to write that in terms of column. So it's up to you whether you are more comfortable to which method. So it's just the same, but I'll just start here instead of this term here. It's commutative, addition is commutative, so there's no problem. So 3x squared plus 6xy. So I'm starting here. Let me just clarify. And I'm multiplying to the first polynomial minus 3x. Then what we do when we proceed to the second term, we already put that in the column of the same of the like term. So like for instance here, that's negative xy. So I'm already looking for the similar term at the same time. Okay, so but this one, there's no similar terms. So I'll just do another column, negative 2y squared, and then plus y, because there's no y squared in the first row, and there's no there's no y. Okay, then negative 5, so that's negative 5x. So I already have an x here, so I'm going to place that in the column of negative of this similar term, like term. Negative 10y, and then I don't have a column for constant, but since I'm out of space here, I'm just going to write it here. Okay, so what is the advantage of this one? You already have everything in this same column, all the like terms. So it's easier to simplify. Okay, so that's why some people would do this type of solution so that you can just easily simplify them. Okay, and if you compare, okay, you get the same answer except for the ordering, but it doesn't matter. Okay, now what will be helpful if you want is to do the special product. So like for instance, for this one, instead of, this is the long method, you have to distribute x squared minus xy, and then you multiply this positive xy minus y squared. So if you simplify, this is equal to x squared minus y squared. So you just have an extra thing to compute when you want to do the long division. Okay, so that's why you have an advantage if you know this special products. So these are not the only special products. There are more, but this would be helpful to us. So I will be illustrating them, and then you can see that the computation is faster. Okay, so for this one here, I have the formulas first here, but we won't be having these formulas when we have our exam. Okay, so this is not very as straightforward as this one. So I'm just going to explain. Like this is the x in our formula here, and this is the y. So you have what you call the product of sum and difference. So this is your x and this is your y. So if you look at the formula here, it should be x squared minus y squared. So that means this is the x that we are applying to our formula. Okay, and then minus, this is the y, z squared. Then we take the square of that. Okay, so we apply the rule again for the exponent. 3 squared, 9, x squared, multiply 10. Okay, so you multiply. Okay, then minus z raised to 4. So imagine how this will take lesser time to do rather than do the long division. But it's not a very big concern. If you do the long division, you should end up with the same final answer. Okay, this one will be for square of a binomial. Here you have two terms. So we square the first term here minus twice the first times the second term plus the square of the second term. Okay, so there you go. So the difference between these two will be on this part of the sign. Okay, so if it's a difference, this is minus, and then if this is a sum, this is plus. Then we simplify, so 9x squared. I'm using similar so that it's easier for us to do some of the computations. So 2 times 3, 6xy raised to 5 z squared, okay, plus z raised to 4. Okay, so again, there's no harm in doing the long division. I'm just going to illustrate what will happen. If you do the long division, then you're going to write it in this form. Okay, and then you're going to multiply and distribute this one by one, which you would still end up with the same value. Okay, then lastly, this one is for the cube, no? But we rarely have this, but still, how do we do this? You take the cube of the first term, this is what I am illustrating, minus, okay, so the x is the first term, no, that I am calling. So times 3x raised to 5 squared. And then you still have to multiply that with the y, c squared. Okay. Plus, okay, so look at the sign. The sign alternates. Okay. 3 times x. Okay. And then you have to, let me rewrite everything in a lower line. Okay. So again, the first term raised to 3 minus 3 times the square of the first term times the second term. So if you notice, I'm not trying to memorize this as x cubed minus 3x squared y. I'm trying to use first term and second term because it would be easier and less complicated. First term, okay, and then this is the second term. We take the square and then minus the second term raised to 3. Okay, so simplify to 3 cubed is 27, x cubed y raised to 15. Now, if you can do it all at the same time, it would be better. So you can just simplify this mentally. 9 times 3, again, 27. And then we have x squared, y raised to 10, and then z squared. Okay, here we have, there's no number here, there's no constant. So 3 times 3, 9, x, y raised to 5, and then this is z raised to 4. And lastly, to simplify this is z raised to 6. So actually, for this problem, it would be beneficial to do the special product. But in the later lessons that we will be having, we won't be doing much of an expansion for cube. No, it's usually a square. Okay, so this is the end for the addition, subtraction, and multiplication of polynomials.